Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the TEAS. We have been solving math problems out of this book here. The study manuals for the TEAS. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 83. Please turn to it. Page number 83, and today is our lesson number 33. On page 83, we deal with the concept of ratio and proportions. Do you know the difference between the two concepts? What's the difference between a ratio and a proportion? Well, a ratio and proportions are two different animals. A ratio, let's begin here. A ratio deals with like things. Proportions, on the other hand, deals with unlike things. Like things as in similar things. Proportions, on the other hand, deals with dissimilar things. Things that cannot be added or subtracted. Ratios deals with things that can be added or subtracted. For example, in ratios, we can talk about the ratio of boys to girls. So if somebody tells us the ratio of the boys to girls is 40 to 30, then it's quite reasonable to ask ourselves, how many students are there altogether? Well, there are 70. We can add them. We can talk about ratio of red cars to blue cars in a parking lot. So if the ratio is 10 to 5, well, there are 15 cars in the parking lot, assuming that they are either red or blue. We can add or subtract because they are both cars, red cars and blue cars. We can talk about the ratio of daffodils to roses in the garden. And if we are told that there are 2 daffodils for every 12 roses, again, there are 14 flowers altogether. However many roses there are, however many daffodils there are, if we add them up, that's the total number of flowers of roses and daffodils. We can add them, we can subtract them because they are similar things. In proportion, one cannot do that. In proportion, we are dealing with dissimilar objects. We are dealing with unlike things. For example, in proportions, we talk about let's say miles and gallons. Miles and gallons. So if we are told that we get 30 miles for 1 gallon, and then we may go on to ask, so how many miles will I get if I have 3 gallons? But at the end, it will not make, so in 3 gallons, of course, we'll go 90 miles. We're dealing with miles and gallons. Those are the two things we're dealing with. They cannot be added or subtracted. It will not make any sense to ask at the end, so how much is 5 miles? How much is 5 miles plus 2 gallons? It makes no sense. This statement makes no sense. We cannot go around asking ourselves how much is 5 miles plus 2 gallons. We cannot add them, we cannot subtract them. Here's another example. For example, if somebody tells you, there's books and dollars. So if you're told that we can buy 3 books with $12, the question is, how many books can we buy with $30? Well, $30 actually would not go evenly. I just realized 3 divided by 12 is 4, so let's make it 40 or 20. 3 divided, so here you can see three books for $12, each book costs $4. How many books can we buy with $20? The answer, of course, is 5. But at the end, it will make no sense. So this is a proportion question. It is a proportion question because we're dealing with books and dollars. These are dissimilar things. They cannot be added or subtracted. It will make no sense at all at the end for us to ask, so how much is 3 books plus $37? This is an absurd question. It has no meaning. Books and dollars are dissimilar things. Similarly, if we go on to say, for example, 3 boxes occupy so much space, how much space will 5 boxes occupy? At the end, it won't make any sense to say, so how much is this many boxes plus this much space? We cannot add them. They are dissimilar things. They are proportions. That's the first difference. Second fundamental difference is that ratios are unit free. Ratios have no units because the units cancel out. We're talking about boys to girls, 40 to 30. It's just 4 to 3. We say 4 to 3, but it has no units. It has no units because boys and girls, they are people. The units cancel each other out here. Similarly, when we talk about the ratios of students to teachers, there are 30 students for 3 teachers. The ratio is 10 to 1. That's all, 10 to 1. Nobody's going to ask you 10 to 1 what? It's just 10 to 1. Ratio is 10 to 1. Ratios have no units. They are unit free because the units cancel each other out from the top and the bottom. Because they are similar things, therefore units gets cancelled out. Proportions, on the other hand, must have units. Otherwise, they won't make any sense. Proportions without a unit makes no sense. Proportions always have units. Proportions must have units. For example, you will say miles per gallon, or you might say dollars, or rather books per dollar. How many books per dollar, or dollars per book, whatever you want to call it. Dollars per, whatever might, it does make no difference how you set it up. Or you might say words in minutes. If I tell you that I can type 30 words per minute, if I tell you that I can type 30 words per minute, it is quite reasonable to ask ourselves how many words can I type in 5 minutes. So here we have to have units. Words per minute, that's the unit. The unit here is words per minute. Unit here is miles per gallon. Unit here is dollar for one book. How many dollars do I have to pay for one book? $4 for one book, whatever the unit. But it must have a unit. Miles per gallon, dollars per book, words per minute, whatever the proportions happens to be. It must have a unit. You understand? Now that we understand the fundamental difference between the two concepts, let's do the problem. First problem. Let's do the first problem. Where can we do it? I need to erase this thing. I'll give you a second. I'll get out of your way. Just give me 1 second, and then we'll do the problems. So remember the two fundamental differences between the two concepts. The first difference is that ratios deal with like things, proportions deal with unlike things. Ratios are unit free, proportions without a unit has no meaning. Proportions must have units. Number 1. Question number 1 that they give us, they're simply asking us, by the way, this question number 1 that we're about to do, 2.37, it is worded in a bloody awkward way. All they're asking here is this. They want a ratio of 30 minutes to 4 hours. That's all they want. They want a ratio of 30 minutes to 4 hours. That's all they're looking for. What's the ratio? Well, let's find out, shall we? So here is the minutes, here is the hours, but they are different units right now, so it's 30 minutes, and we are told 4 hours. You have to convert these 4 hours into minutes. How many hours in a minute? We have to convert these hours into minutes. How many minutes in 4 hours? We have 4 hours, the same as 4 times 60 minutes. 4 times 60 minutes. And 30, 0 is going to drop out. If we divide top and bottom by 6, this 3 drops out and 6 becomes 2. So the ratio of 30 minutes to 4 hours is same as 1 to 8. 1 to 8. This is how we say it. 1 to 8. The ratio of 30 minutes to 4 hours. They're asking us what is that ratio. The answer is the ratio is 1 to 8. That's all. Number 2. As I said, it's written in a very silly way, a very annoying way. Number 2, which is on page number 83, 2.38. So that was the proportion question. The one we just finished is the proportion question. Let's see what the next one is. It says last year at the local community college, 1,250 students were enrolled in 50 sections. You see, we're dealing with students and sections. The students and sections. These are two unlike things. We cannot add or subtract. It will make no sense to ask ourselves, so how much is 3 students plus 3 sections? Doesn't make any sense. These are dissimilar things. We're dealing with a proportion problem. And we are told that we have 1,250 students in 50 sections. Always set it up like this. Put down your units first, like this. Put down the units first like this. Put an equal sign. Put down the first pair. They always give you one pair. And the second pair, one of the items is going to be missing. Either the top or the bottom is going to be missing. And we just have to solve for it. And they go on to ask us, this year 1,550 students were enrolled in the courses, and they go on to tell us that if the number of students per section is the same for each of the section and does not change from year to year, in other words, number of students per section is fixed. Obviously it has to be fixed, otherwise we cannot solve it. The question simply is, how many sections do we need if we have 1550 students? There are a couple of ways we can go about it. First, we'll solve it as a proportion problem, and then I'll show you a different method. In a proportion problem, it's very simple. You cross multiply 1250 times x. 1250 times x equals 1550 times 50. And therefore x equals to, x will equal to 1550 times 50 over 1250. And now all we have to do is simplify it. Divide top and bottom by 10. If we divide top and bottom by 10, we can cross out this 0 right here. I was doing it very carefully. If you notice, I paused for a second. I had a choice. I could cross out this 0 with that 0, or I could cross out this 0 with that 0. I chose to cross out this 0. Do you know why? I crossed out this 0 and not that 0 because 155 is not a multiple of 25. I realized that 125 is a nice multiple of 25. How many 25s? How many 25s in 125? 125 has 5 25s. 100 has 4 25s. So I realized that the bottom is nice multiple of 25, and my eyes were looking for a nice multiple of 25 on the top. In the top, 50 is the multiple of 25. So had I taken out the 0 from the 50, then we would have no choice but to divide top and bottom by 5, and it will just lengthen the process. By dividing by 50, we can just do very quickly. So how many 25s in 50? 50 has 2 25s. Let's divide the bottom also by 25. 125 has 5 25. Now let's divide top and bottom by 5. How many 5s in 15? 15 has 3 5s. Technically what's going on is this. Okay? Let me start again. We're trying to divide 155 by 5. That's what it is. 155 by 5. And what we're asking ourselves is, how many 5s in a 0? 0 has no 5s. That one, how many 5s in a 1? How many 5s in a 1? 1 has no 5. That one goes and joins the 5, becomes 15. How many 5s in a 15? 15 has 3 5s. How many 5s in a 5? 5 has 1 5. And that knocks out this 0. So it's 15 has 3 5s, and this 5 has 1 5, that knocks out this one. So it's 31 times 2, 31 times 2, the answer is x is equal to 62. So this was one way of doing it. Now I'm going to show you a different way without using the proportion. Let's do it here. The second method would be to first find out how many students per section. We know that they had 1250 students and 50 sections. We can do it right here. We could do it, let's find out. So here we have students and sections. And we are told we have 1250 students and in 50 sections. So listen carefully. So we're going to figure out how many students per section. Once we know how many students per section, we can divide 1550 by that many and we'll figure out the number of sections. Let's see what happens. Divide top and bottom by 0. 0 knocks out. We can knock out a 0. Let's divide the top by 5. How many 5s in a 1? So now we're dividing 125 by 5. And what we're asking ourselves is, how many 5s in a 1? 1 has no 5s. That one goes and joins the 2, becomes 12. How many 5s in a 12? 12 has 2 5s. The remaining 2 5s are 10. The remaining 2 goes and joins the 5 and becomes 25. How many 5s in a 25? 25 has 5 5s. There you go. So it turns out that the answer is 25 students per section. We have 25 students per section. Now at this stage in the game, there are two more choices as to which route we can go. We can either take 1550 and divide that by 25, or we can realize that 1550 is 300 more than 1250. 1550 is 300 more than 1250, each section has 25 students. Since there are 300 more students, there will be 4 sections in 100, 4 more sections in the second 100, 4 more sections in third 100. Because there are 25 students per section, which means it takes 4 sections to make a 100. We have 300 more, which means we'll have 12 more sections than before. This tells us that we will have 12 more sections than before. Well, 12 more sections than before. Before we had 50 sections. So now we have 50 plus 12. Or 62. As you can see, we get the same answer as here, except this is a more traditional way of solving a proportion. This was a different way. So here we set it up as a proportion. What we did here is we figured out how many students per section. So once we knew there were 25 students per section, we asked ourselves, how does 1550 compare with the original number, which is 1250? And we realized that 1550 is exactly 300 more than 1250. Since it takes 4 sections to make 100, it will take 12 more sections to accommodate 300 students. 12 more sections than before. We started out with 50 sections, so we need 62 sections. That's all. I'll see you tomorrow, okay? Bye now.